Good morning, students. Today's topic in chemistry is the electrolysis of the aqueous electrolyte. In the topic of electrolysis, in the subject of chemistry, this is important topic, students. So concentrate yourself. We are going to start now. Electrolysis of the aqueous electrolytes. Aqueous electrolytes are mixtures of two electrolytes, the compound and the water. Water ionizes to produce hydrogen ion H plus and hydroxide ion OH negative. That is, H2O is converted into H plus and OH negative. With the presence of more than one type of the anions and cations, selection of the ions for preferential discharge is based on the following factors. So it means if there are more than one type of the anions or cations, so the selection for the discharge will be based on the following factors. And the factors are, number one, position of ion in the electrochemical series. Second factor is concentration of the ion. And third factor will be nature of the electrodes. So these are the three factors, and we will discuss all three factors one by one. So this is very important, students, so now concentrate very well. Number one is the position of the ion in the electrochemical series. Table below shows the electrochemical series for cations and anions. And here is our electrochemical series. These are cations and these are anions. Ease of the discharge increases. So as we go below the column, ease of the discharge increases. The ion lowest in this series will be discharged in preference to any other ion present. So this first factor will be explained more in detail with the help of an example. And the example is electrolysis of the dilute sulfuric acid, electrolysis of the water. So electrolyte present in the dilute sulfuric acid are H2SO4 and water. Electrodes used in the process are carbon anode and carbon cathode. Ions in the electrolyte present are H plus and OH negative and SO4 2 minus. So cations are H plus and ions are OH negative and SO4 2 minus. Electrode reaction at the anode. OH ions are discharged. OH negative is lower than SO4 2 minus in the electrochemical series. So here are two anions present in the electrolyte. So we will look now at the electrochemical series. So if you look, OH is lower in this series as compared to SO4 2 minus. So OH will ease of the discharge increases as we go down the series. So OH will be discharged. So OH ions are discharged. OH negative is lower than SO4 2 minus in the electrochemical series. And the reaction is this one. 4 OH negative forms 2H2O plus O2 plus 4 electrons will be discharged. This is an oxidation process. Oxygen gas is liberated. At the cathode, there is no competition. Only one cation is present, so that will be discharged. So H plus ions are discharged at the cathode. And the reaction will be 2H plus 2 electrons forms H2. This is a reduction process. Hydrogen gas is liberated. Conclusion: Water is decomposed into hydrogen and oxygen. That is, 2H2O forms 2H2 plus O2. Two volumes of the hydrogen to one volume of the oxygen are collected. H2SO4 is not decomposed. H2SO4 is added to increase the electrical conductivity of the electrolyte solution. As water is decomposed, the concentration of the sulfuric acid increases. So, this was the example. Read it again very carefully. Next, here is another example. An electric current is passed through dilute nitric acid. Name the ions present in the acid solution. So dilute nitric acid is there, so it means HNO3 will be converted into H plus and NO3 minus, and H2O will be converted into H plus and OH negative. So it means ions present in the acidic solution are H plus, OH negative and NO3 negative. So this is the answer of the first part. B part is write equations for the reactions that occur at the anode and cathode. So OH negative and NO3 negative ions migrate to the anode. OH negative ion is discharged due to its lower position in the electrochemical series. So this is the competition between these two ions, OH negative and NO3 negative. So if you look at the electrochemical series, OH negative is lower in the series as compared to NO3 negative. So OH negative will be discharged. So OH negative and NO3 negative ions migrate to anode. OH negative ion is discharged due to its lower position in the electrochemical series, and the reaction will be 4OH negative forms 2H2O plus O2 plus 4 electrons, and H plus ions, there is no competition for the H plus, so H plus ions migrate to the cathode. H plus ions are discharged and cathode reaction is 2H plus 2 electrons forms H2. Hydrogen gas is liberated. Okay, this is the second part. Now the third part is name the products formed at the anode and cathode. So C's part answer is anode products are water and oxygen. This is the anode product. And here is the cathode product, that is hydrogen. Okay, next factor for the discharge of the ions is concentration of the ion. So concentrate yourself, students. This is the second factor which affect the discharge of the ions. The ion present in higher concentration tends to crowd out other ions and hence gets discharged at the electrode. The following ions are not discharged even if they are present in high concentration. And ions are sulfate, nitrate and carbonate. So these anions will not be discharged even if they are present in high concentration. And the cations are potassium, sodium, calcium, magnesium and aluminium. So these anions and cations will not discharged at all even if they are present in high concentration. So this factor will be explained more with the help of an example now. Electrolysis of concentrated hydrochloric acid. So electrolyte is concentrated hydrochloric acid, that is ACl and H2O. Electrodes present in this process are carbon anode and carbon cathode. Ions in the electrolyte are present H plus and anions are OH negative and Cl negative. Electrode reactions at the anode. Cl negative ions are discharged. Higher concentration of the Cl negative ions. And the reaction is 2Cl minus forms Cl2 plus 2 electrons. This is an oxidation process. Greenish yellow chlorine gas is liberated. Okay, for H plus there is no competition. So at the cathode, H plus ions are discharged. And the reaction is 2H plus 2 electrons forms H2. This is a reduction process. Bubbles of the hydrogen gas are liberated. Conclusion. Hydrogen chloride is decomposed into hydrogen and chlorine. And this is the reaction. 2HCl forms H2 plus Cl2. One volume of the hydrogen and one volume of the chlorine are collected. The volume of the chlorine gas collected is slightly less than the volume of the hydrogen gas because a small amount of the chlorine gas dissolves in the electrolyte solution. Another example is here. Electrolysis of the concentrated sodium chloride solution. Electrolyte present in this example are NaCl and H2O. Electrodes present in this process are carbon anode and carbon cathode. Ions in the electrolyte are cations are H plus and Na plus. Anions are OH negative and Cl negative. Electrodes reaction at the anode. Chlorine ions are discharged. Higher concentration of the Cl negative ions. And the equation is 2Cl negative forms Cl2 plus 2 electrons. This is an oxidation process. Greenish yellow chlorine gas is liberated. And at the cathode there is competition between H plus and Na plus. H plus ions are discharged because Na plus ion is too stable to be discharged. So the equation will be 2H plus 2 electrons forms H2. This is a reduction process. Bubbles of the hydrogen gas are liberated. Conclusion. Hydrogen and chlorine are formed. Sodium hydroxide is left behind in the electrolyte. 2NaCl plus 2H2O forms 2NaOH plus H2 plus Cl2. One volume of the hydrogen and one volume of the chlorine are collected. Here is another example. Describe what happens when an electric current is passed through concentrated copper chloride solution using carbon electrodes. So electrolytes present in this process in this example are copper chloride and water. Ions in the electrolyte. Cations H plus and Cu2 plus. Anions present in this example are OH negative and Cl negative. Electrode reactions. At the anode, Cl negative ions are discharged because of the high concentration. And the reaction is 2Cl negative forms Cl2 plus 2 electrons. This is an oxidation reaction. Greenish yellow chlorine gas is liberated. And in the cations, there are more than one cations, and the competition is there between H plus and Cu2 plus. Cu2 plus ions are discharged. Cu2 plus is below H plus in the electrochemical series. Cu2 plus 2 electrons forms copper reduction. Pink solid of the copper metal is deposited. Conclusion: copper chloride is decomposed into copper and chlorine because copper is obtained and chlorine gas is obtained. Concentration of the copper chloride solution decreases with time. Water is left behind in the electrolyte cell solution. The blue copper chloride solution turns colorless. Okay, the third factor which is affecting the discharge of the ions is types of the electrodes. So students, this is the third factor which we are going to discuss. So concentrate yourself now. The type of the electrode can influence the discharge of the ions. Certain electrodes can take part in electrode reactions. And this topic is going to be explained with the help of an example. Electrolysis of the copper sulfate using copper electrodes. Electrolyte present in the example are copper sulfate and water. Electrodes are copper anode and copper cathode because this is given in the example. Ions in the electrode are H plus and Cu2 plus. And ions present in the electrolytes are OH negative and SO4 negative. Now, electrode reactions. At the anode, OH negative and SO4 negative ions are not discharged because of the presence of the certain electrodes. Copper atoms lose electrons more readily as compared to OH negative and SO4 negative ions. Reaction is copper forms Cu2 plus 2 electrons. This is an oxidation process. The copper anode dissolves. So, the point to remember is electrolysis of the copper sulfate and copper electrodes are there. So, copper. That's why copper will be discharged. And at the cathode, Cu2 plus ions are discharged. Cu2 plus is lower than H plus in the electrochemical series. Cu2 plus 2 electrons forms copper. This is reduction process. Pink solid of the copper metal is deposited. So again, I'm telling you, because electrolyte is copper sulfate and electrodes are also copper, so that's why only copper will be discharged. Conclusion: copper is transferred from anode to cathode. Copper sulfate is not decomposed. Concentration of the copper sulfate solution remains unchanged because only copper is transferring from anode to cathode. Okay, this factor is further explaining through another example. An electric current is passed through silver nitrate solution using silver electrodes. So now look carefully. Electrolyte is silver nitrate solution and electrodes are silver. So only silver will be discharged. The processes: electrolyte is silver nitrate and water. Electrodes are silver anode and silver cathode. Ions in the electrolyte are cations are H plus and Ag plus. Anions are OH negative and NO3 negative. Electrode reactions: at the anode, neither OH negative nor NO3 negative ions are discharged. So these both will not be discharged because each silver atom loses one electron to form Ag plus ion. And the reaction is Ag forms Ag plus one electron. This is oxidation process. The silver anode dissolves. And at the cathode, Ag plus ions are discharged. Ag plus one electron forms Ag. This is reduction process. Silvery solid of the silver metal is deposited. Conclusion: silver is transferred from the anode to cathode. Silver nitrate is not decomposed. Concentration of the silver nitrate solution remains unchanged. So students, this was the lecture. This is very important topic as far as your chemistry papers are concerned. So read this lecture again very carefully and make your notes. Thank you so much.